Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over some more Lewis dot structures. So let's get into this. So in this video I'm going to go over how to draw Lewis dot structures. I've got a list of molecules here or substances that I'm going to use to show you how to go through the steps in drawing your Lewis dot structures. Now I need to state from the beginning that if you follow these simple steps, you should be able to do any Lewis dot structure for any substance given to you by your professor or teacher. Okay, so let's get into this. So the first step is always to to list out the number of valence electrons total in your molecule. So, so that's the first step. What is the total number of valence electrons in your substance? So if we start with ACH3Br, so we are going to total up the number of valence electrons. So carbon is in group 4A, so it has 4 valence electrons. So we're going to add 4. Now, hydrogen has 1 valence electron each because it's in group 1A, so it's going to have 1 valence electron. I have 3, so 3 times 1 is 3, so I'm going to add 3 to my total. And bromine is in group 7. Therefore, it has 7 valence electrons. I only have 1 bromine, so I'm going to add 7, and I add that together, and I get 14 total valence electrons. These are the electrons I'm going to use to put together my Lewis dot structure. So that's the first step. The second step is to draw your skeletal structure, and therefore you need to determine what atom or what element is the first, what is the central atom. So again, there's a few ways you can determine the central atom. One, the central atom is usually the first one in the formula, so that's a giveaway. Two, it's the lesser electronegative atom that's in your molecule. If you're looking at electronegativity, you would determine that the more electronegative atom is not going to be the central atom. It's the lesser electronegative atom. So if we look here, carbon is written first, so we would suspect that carbon is going to be our central atom. We would also suspect that carbon is going to be the lesser electronegative atom because it is the central atom because it is the lesser electronegative atom. Also, another thing you want to look at is how much of the bonding will occur, which element will bond the most, and the way you could look at that is by looking at the Lewis symbol for each element and seeing which one has more unpaired electrons, because the one with the more unpaired electrons is going to be the central atom, because central atoms need to be bonded to multiple things. So what do I mean by that? So the Lewis dot symbol for carbon or for any element is basically you're drawing the valence electrons around the symbol. Excuse me. So carbon has 4 valence electrons, so I would do the dots like this going around and then pairing up if I have more. So 1, 2, 3, 4. So that's it. And then hydrogen only has 1 valence electron, so I'll put the dot there. And then bromine has 7 valence electrons because it's in group 7. So bromine, the Lewis dot symbol would be 1, 2, 3, 4. Now I'm going to pair up 5, 6, 7. So looking at here, both the hydrogen and the bromine only have 1 unpaired electron, so they're likely to only bond once. Carbon has 4 unpaired electrons, so that's going to bond 4 times. So again, carbon is going to be our central atom here. Okay, so now that we have that, we can just draw our Lewis dot, our skeletal structure. So carbon is going to be the center. I'm going to bond the hydrogens, and I'm going to bond the bromine, all with a single bond. No double, no triple bonds yet, just single bonds at this point. So now that I have my skeletal structure, I'm going to subtract out the number of electrons I used in creating my Lewis dot structure. So I've got 4 single bonds, 2 electrons per bond, that's 8 electrons. So I'm going to subtract out 8, and that's going to give me 6 more electrons to use. Okay, so this is step 2. Step 3 is if I have electrons left over, then I want to put lone pairs on the outer atoms to give them an octet if they need it. So I have 6 electrons left over. The hydrogens do not need an octet. They're happy with 1 bond. So then we go to the bromine. Bromine needs an octet. So I have 1 bond, that's 2 electrons. So I need 6 more electrons. So I'm going to put 3 lone pairs on my bromine. And I used up 6 electrons, so I got to subtract that from my total. And I'm left with no more electrons. So at this point, the next step, this is step 3. I finished step 3 with the lone pairs on the outer atom. Step 4 would be if I have electrons left over, you would add those, all of the leftover electrons would be added to your central atom as lone pairs, right? So if I had 2 electrons left over, I would put 1 lone pair on the carbon. If I had 4 electrons left over, I would put 2 lone pairs on my carbon. But in this case, I don't have any electrons left over, so I can skip step 4. And step 5 would be if my central atom doesn't have an octet, then I would have to move electrons from one of the outer atoms, and create double and triple bonds. But we're getting ahead of ourselves because once you are out of electrons, what you want to do is check the Lewis dot structure to see if everything's fine. If everyone's happy with an octet or with whatever number of electrons they're happy with, then you're done with the Lewis dot structure and you don't need to do any more. So here we'll double check. Hydrogens, again, we said that they were happy with only 2 electrons. They were happy with their single bond, so they're good. Bromine, we said, has an octet because it has 1 bond, which is 2 electrons, and 3 lone pairs, which is 6. So 6 plus 2 is 8. So bromine is happy with 8. And then carbon has 4 bonds, 2 electrons per bond. That's 8 electrons. That's your octet. So carbon has an octet. So everyone is happy in this structure. So this is your Lewis dot structure for this formula, this substance here. Okay, let's go on to B and see how to do that one. Again, same steps. So CH2O. Now, this is an organic molecule. Organic molecules are identified by the fact that they have carbon, hydrogen, and oxygen, and sometimes nitrogen and sulfur, right? So in this case, one of the things you want to pay attention to is the ordering of the elements, because that will kind of tell you the bonding of that of the elements to each other and kind of tell you what the structure is or what your skeletal structure will be. But I get ahead of myself. So the first step is to total up the number of valence electrons in your substance. So again, carbon has 4, so I'm going to add up 4. I have 2 hydrogens. Each hydrogen has 1 electron, 1 valence electron. So that's going to be 1 times 2 hydrogens. That's going to be 2. So I'm going to add 2. And oxygen is in group 6, so that has 6 valence electrons. I only have 1 oxygen, so I'm going to add 6. So 6 plus 2 is 8, plus 4 is 12. So I have 12 electrons. So now I have my total electrons. Now I'm going to do step 2. So step 1 is done. Step 2, draw my skeletal structure. So again, various ways to figure out what your central atom is. Hydrogen is never going to be a central atom because it only bonds once. Oxygen could be a central atom, or carbon. So if we compare carbon and oxygen, Oxygen is the more electronegative atom. Then carbon would be the central atom based on electronegativity. Carbon is written first, so it's most likely going to be the central atom. Also, if you draw the Lewis structure or Lewis symbol of each element, you'll find that oxygen has only 2 unpaired electrons, where as before, we saw that carbon has 4 unpaired electrons. So lots of different ways to figure out what your central atom is. So your central atom for this one is carbon. So carbon, and we're going to bond the hydrogen to the carbon. Now in this case, all of the atoms are bonded to the carbon. One thing you can remember is that hydrogens are bonded usually to the element or atom that they are following. So carbon is here, so hydrogen is following carbon. So we can see that hydrogen is going to be bonded to the carbon. And then oxygen is also going to be bonded to the carbon. So that's generally the rule for when you're trying to figure out your organic molecules. So I'm going to draw my skeletal structure. So here's my 2 hydrogens and my oxygen bonded to the carbon. Okay, so that's step 2. Now I'm going to have to subtract out the electrons that I used. So I have 2 for each bond, 3 bonds, that's 6 electrons. So I'm going to subtract out 6 electrons, and I have 6 electrons left over. So now for step 3 says you're going to add lone pairs. If you have electrons left over, and I do, you're going to add lone pairs to the outer atoms to give them an octet if they need it. So again, hydrogen doesn't need an octet. They're happy with a single bond, but oxygen needs an octet. So I'm going to add lone pairs to my oxygen like so. And so now that I have that, that's the only outside atom that I need to add lone pairs to. So now I'm going to have to subtract that from my total. I use 6 electrons, so I'm going to subtract out 6 from my total, and I have no electrons left over. So at this point, I double check my Lewis dot structure to make sure everything is fine. So hydrogens, again, are happy with 1 bond, so that's good. My oxygen, as I pointed out, has an octet, 1 bond, 2 electrons, plus the 6, that gives 8. But if you look at the central atom, you'll see that it has 1, 2, 3 bonds. That's 6 electrons total, 2 electrons per bond. It does not have an octet. So step 4 would be, if I have electrons left over, I would add those electrons as lone pairs to my central atom. But I don't have any electrons left over, so I got to skip step 4 and move on to step 5. Step 5 says that if you do not have any electrons left over and your central atom still does not have an octet, then what you do is you need to move lone pairs from outer atoms to create double and triple bonds until your central atom or central atoms are satisfied or have their octet. Okay, so in this case, the only atom that has lone pairs on it is the oxygen. So I'm going to take a lone pair from the oxygen and make a double bond. And so I'm going to erase this pair of electrons, and I'm going to create a double bond. Now carbon has 4 bonds. So it has an octet. Notice that nothing changes really for the oxygen. It has 2 bonds now and 2 lone pairs. That's still 8 electrons. Now notice also bonding patterns. Bonding patterns are also useful. Oops. Sorry about that. Bonding patterns are also useful. So carbon loves to have 4 bonds, and you can see that carbon has 4 bonds. And oxygen loves to have 2 bonds and 2 lone pairs. So it has 2 bonds and 2 lone pairs. So that fits the bonding patterns for these elements. And so, ladies and gentlemen, that is your Lewis dot structure. Okay, let's try C for Cn. So we have Cn minus. So I'm going to erase this so I can start over. So Cn minus, this is an ion. It's a cyanide ion. And we have this negative charge here. So we'll have to deal with that. So again, the steps are the same. So the first step is to get the total number of electrons or valence electrons for our substance here. So again, carbon is in group 4, so it has 4 valence electrons. Nitrogen is in group 5, so it has 5 valence electrons. So we have a total here of 9 electrons. Now, what about the charge? So you can't forget the charge. The charge will actually tell you about your total number of electrons. So if you have a negative charge, that means that you are going to have to add extra electrons. So the negative charge means you have more electrons than you should, in a manner of speaking. So if you have a negative charge, you're going to add that many electrons to your total. So here I have a -1, so I need to add one more electron to my total. If this was a -2, then I would have to add 2 more electrons to my total. If it was a -3, I would have to add 3 more electrons. If it was a positive charge, then positive means you're going to take away electrons from your total. That means you're missing electrons, right? So if I had a positive charge, then I would remove 1 electron from my total. If I had a positive 2 charge, I would remove 2 electrons from my total. If I had a positive 3 charge, I would remove 3 electrons from my total, and so on. So in this case, I have a -1, so I'm going to add another electron, and that's going to be 10 total electrons. Now that I'm done with step 1, time for step 2. For step 2, skeletal structure. Now here, you only have 2 atoms, but it's important to identify still what the central atom is, because to follow the steps, you gotta know what your central atom is. So again, the carbon is written first. So that's most likely your central atom. It's the lesser electronegative atom. It's the one that has more capability of bonding, right? So on and so forth. So your carbon is going to be your central atom, and then you're going to bond that to the nitrogen like so. So here is your skeletal structure. So we used 1 bond, and so we're going to subtract out 2 electrons for that 1 bond, and that's going to be 8 electrons left. So now I have 8 electrons. So what do? So 8 electrons. The third step is I'm going to add lone pairs to my outer atom. This is why it's important to even identify what your central atom is, even though there's only 2 atoms. In this case, nitrogen is going to be our outer atom. So we're going to add lone pairs to our outer atom to give it an octet. So we're going to go ahead and give that 3 lone pairs. And so now nitrogen has 3 lone pairs. That's 6 electrons plus the bond. That's 8. It has an octet. So now we have to subtract out 6 electrons. So we're going to subtract out 6. And we have 2 electrons left. So now we go to step 4. Step 4 says that if you have extra electrons, you're going to put all of them onto your central atom as lone pairs. So I have 2 electrons left, so that's 1 lone pair. I'm going to add a lone pair to the carbon. And so now I have carbon here. And so what you're going to do is you're going to now subtract out the electrons you use. So I use 2 electrons there, and then you have 2 there, and that's going to be 0. And again, as I said before, when you hit 0, you double check your Lewis dot structure to see if everything is good. If everything's good at this point, then you're done. Here, though, you have nitrogen has an octet, but if you look at carbon, carbon has a bond, and it also has a lone pair that's only 4 electrons. So it needs 4 more electrons. I don't have any more electrons to give, so I have to go to step 5, which is to move electrons, lone pairs, from your outer atom to create double bonds. So notice it's from the outer atom, not the central atom. So here, nitrogen is our outer atom. So we're going to have to move electrons here as bonds to give carbon an octet. Since carbon needs 4 electrons, we're going to have to move 2 lone pairs to create 2 bonds. So we can take this lone pair, create a bond. We can take this lone pair, have it shared, create a bond. And when we do that, if I erase this like so. So now I have my nitrogen with 1 lone pair, and I'm going to create 2 more bonds. And so now I have a molecule or a structure here with 3 bonds, a triple bond here. Now if we count the number of electrons, we have 2 for the lone pair, we have 2 for each bond, that's 6. 6 plus 2 is 8. Now carbon has an octet. Same as nitrogen, still has an octet. Same as carbon. Lone pair plus 3 bonds, that's going to be an octet. So everyone's happy. So the other thing you got to keep in mind is whenever you have an ion with a charge, you got to have square brackets around your Lewis dot structure with the charge on the outside. Let me make that bigger. So that would be the proper Lewis dot structure for this molecule. Okay, next we have CF3CHCl2. So this is an organic molecule, again, because it has carbon, hydrogen. It does have halogens in it. But the way you figure out the skeletal structure is the same way as here, and I'll explain that in a moment. So first thing we need to do is determine the number of valence electrons. So again, we have carbon, which is group 4, so that's 4 valence electrons. We have 2 carbons here, so that's going to be 2 times 4, which is 8. And we're going to add to that the hydrogen, right? So we have hydrogen here. Or let's do fluorine first. I guess we could do fluorine. Fluorine is a halogen. It's in group 7, so it has 7 valence electrons. 7 times 3 is 21. Okay, and we're going to add to that. Now we can add the hydrogen. We only have 1 hydrogen. It's in group 1, 1 valence electron. So we'll add a 1. And then finally we have chlorine, which is a halogen. So again, 7 valence electrons because it's in group 7. And therefore, and we have 2 of them, so that's 14. So we're going to add that. And so there's no charge, so we don't need to worry about adding charge or anything or subtracting. So we have 8, and then 21 plus 20 plus 1 is 22. 22 plus 8 is 30, and then we have 14. So that's going to be 44 total electrons, valence electrons. Okay, now that we have step 1 completed, we're going to do step 2 for the skeletal structure. Again, here, we're going to determine what the central atom is. And again, carbon is written first. Hydrogen is never going to be a central atom. Halogens, fluorine and chlorine, are much more electronegative compared to carbon. So carbon is your central atom. But look, we have 2 carbons, so we have 2 central atoms here. So if we draw our structure, we're going to start with the carbon. And the way we draw our structure is we remember that anything that follows the carbon is bonded to that carbon. And there might be one exception to that, but we'll get to that when we get to that. But here, so the fluorines here are bonded to that carbon. So our follow that carbon, so the fluorines are bonded to the carbon. Let me bring this down so we have room. So I have fluorines And now the carbon follows the carbon. So the carbons are going to be bonded to each other. So carbons, if you have more than one carbon, most likely they're bonded to each other. So carbon follows. Now we have a hydrogen here. The hydrogen is directly following the carbon, so that is bonded to the carbon as well. So we could put the hydrogen there. And then we have the two chlorines. The two chlorines are bonded to the carbon as well. They're not bonded to the hydrogen. They can't be because the hydrogen is already bonded to the carbon. Hydrogen can only bond once. So you're not going to bond anything else to the hydrogen. So the only place it can be bonded is to the carbon. So we'll bond the chlorines to the carbon as well. Okay, so next, we got that straight. So we're going to subtract out the electrons. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 bonds. That's 14 electrons. And so we're going to subtract out 14, and that's going to give us 30 electrons left. That's step 2. Step 3, add electrons to your outer atoms, giving them an octet. So that means we're going to give octets to our fluorines and chlorines. So let's go ahead and do that. So each one is going to get 3 lone pairs, like so. 3, 3, 3. Okay, how many electrons did I use? I used 6 for each one. I have 5 of these. 5 times 6 is 30. So I've used up 30. And I have 0 electrons left. So at this point, I double check my Lewis dot structure. And you'll notice that everyone is happy with octet except for hydrogen. So we're done. That's the Lewis dot structure. All right, so finally, let's do this bad boy here. So we have this one. So again, carbon is going to be the central atoms again for the same reasons. So we're going to, oops, I forgot to total these. So let's go ahead and total the electrons. So we have 2 carbons. 2 times 4 is 8. And then we have 4 hydrogens. 4 times 1 is 4. Plus the oxygen, which is in group 6, so that's 6. Add those together, and we got 18 total electrons. Now we do the skeletal structure, the 2 carbons. Now notice the hydrogens, the 3 hydrogens follow the carbon. So we're going to bond those hydrogens to the carbon. This carbon follows, so that's going to be bonded to the carbon. And then this hydrogen follows directly after the carbon, so that's going to be bonded to the carbon. And this oxygen is going to be bonded to the carbon as well. So there's my skeletal structure. Next is adding electrons to the outer atom. So notice I used 1, 2, 3, 4, 5, 6 bonds. So I'm going to subtract out 12 electrons. That gives me 6 more electrons left. Now I'm going to add lone pairs to my outer atoms. The only one that I can add lone pairs to is the oxygen. So I'm going to add 3 lone pairs. Now it has an octet. So I'm going to subtract out the 6. And now I have 0. Now I'm looking at this here. And I'm double checking the Lewis dot structure because I have 0 electrons. So I'm double checking. And I find that this carbon here only has 3 bonds. It needs 1 more bond. So now I have to go to step 5. I need to move electrons to create a double bond. So I'm going to erase that, put a double bond. Now everyone is happy with an octet except for the hydrogens, of course. So this is the Lewis dot structure for this substance there. And that, ladies and gentlemen, is how you do it. Notice the bonding patterns: 2 bonds, 2 lone pairs for the oxygen, 4 bonds for each carbon, 1 bond for each hydrogen. I hope this video was helpful. If you enjoyed this video, then please like, share the video with the others. Please hit that like button. Also, subscribe to my channel. Make sure you hit that notification bell so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.